Hello, dear students. In previous classes, we had started the series of elementary mathematics for class 11th. In last class, we studied about elementary concept of differentiation. And now, students, in this class, we will study about the elementary concept of integration, elementary concept, concept of integration, integration. So, students, in this class, we will talk about integration. What is the meaning of integration and what is the application of integration in physics? So, students, first, we will talk about integration. So, the topic is integration. So, students, the literal meaning of integration is summation. Summation. And we all have studied summation in mathematics. And this is a mathematical term which means to sum up all the terms. And students, when a parameter is determined in a small interval, suppose that we have any function and that function, if that function is measured over very small intervals, if that function is measured over very small intervals, and students, and all those contributions are summed up. If all those contributions are summed up, we obtain the integral of the function. I am repeating once more. When a function is measured over a very small interval and all the contributions of the functions, if they are summed up, we obtain the integral of the function. We obtain the integral of the function. Now, students, we'll proceed further. Students, if we will talk about present standard integration, then students, present standard integration is used to determine the area found by the curve y is equal to fx with the x-axis. Area of the curve y is equal to fx with the x-axis. Let me upload one diagram so it will become more clear from there. Now, students, if you will see in this figure, there are two axes, vertical axis and horizontal axis, and this is a very thin strip, and the width of this strip is dx, and the length is y. And if you will write the area of this, if you will write uh, area uh, of the strip, actually this strip is very thin. So it will be how much? Length into breadth. So length was y and breadth was dx. Now, students, if you will integrate y dx, and this y dx it is equal to fx. Let it be any function fx. Fx is equal to y dx. And students, if you will integrate fx dx, here y is equal to fx, and if we'll integrate fx dx, then students, area is determined. Area is determined. Area is determined. Here, students, y dx is equal to fx dx. Here y is equal to fx. So make the required correction. Now students, integration is represented by this symbol. This is the symbol of integration. And students, if I am writing like this under the symbol fx dx, it means we have to integrate fx with respect to x. Suppose I am writing y dx, it means I have to integrate y with respect to x. Suppose I am writing x dy, it means I have to integrate x with respect to y. And students, if you will see about the process of integration, students, integration integration is the integration is the reverse integration is the reverse process of differentiation. Integration is the reverse process of differentiation. Now students, if I am differentiating fx d by dx of fx, and we are getting a new function gx. So here students, gx is the differential coefficient of fx. We have studied differentiation. If you will differentiate one function, then you will get another function, and that another function is the differential coefficient of first function. Now students, if we will integrate gx, with respect to x, then students, we will get fx plus c. Here students, constant, this c is a constant and it is called integration constant. Integration constant. Integration constant. Now students, this constant is put, this constant, now students, this constant is put due to the reason that students, functions having same differential coefficient may differ in constants, and students, such integration, such the integration which we are studying, students, this is called indefinite integrals. Indefinite integrals. So students, let me give you one example. Suppose you have d by dx of x square. If you have to differentiate x square with respect to x, then how you will differentiate? It will be 2x. How it will be 2x? As you all know the formula, d by dx of x to the power n, it is equal to how much? Nx to the power n minus 1. So use this formula. Here n is what? 2. 2x, n minus 1. 2 minus 1 will be 1. So you will get 2x. Now students, Now, next, if you will differentiate x square plus 5 with respect to x, d by dx of x square plus 5, you will again get 2x because 5 is a constant and its differentiation with respect to x, it will be 0. And students, if you will differentiate d by dx of x square minus 3, again you will get 2x. So students, see here, constants are different, but we are getting here same differential coefficient. So students, all these functions have the same derivative, but they are differing by constant. Now students, d by dx of x square plus c, it will be equal to 2x. Here c is a constant. Now students, that's why indefinite integrals include constant. So students, that's why constant c is included in indefinite integrals, because students, all the functions having same derivative, they differ by constant. So students, that's why we include constant c in indefinite integral. Now friends, next is there are some formulae for integration. So students, we will study about that, some formulae for integration. Formulae. Students, there is one most frequently used and important formula is the power formula. And if you have integral x to the power n dx, it is equal to x to the power n plus 1 upon n plus 1 plus constant c. We always add integration constant c in indefinite integrals. Now students, suppose we have y is equal to x to the power 5, and we have to integrate y with respect to x. So let's just see how to integrate it. X to the power 5 dx. Now friends, we know this formula. What is n here? Compare from here. Compare these two. N here is 5. So students, we will apply this formula. Integral x to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus c. So here x to the power 5 plus 1 upon 5 plus 1 plus constant c. So students, if you will simplify this, it will come out to be x to the power 6 upon 6 plus constant c. So students, in this way you have to evaluate the integral in the power form. Now students, suppose you have y is equal to 3x to the power 11 by 2, and you have to integrate it with respect to x. So just see how you will do. 3x to the power 11 by 2 dx. We have to integrate it with respect to x. So here 3 is a constant. So constant will be put outside the integration. Now you have to integrate x to the power 11 by 2 dx. Now students, we will use this formula, power formula. Again, x to the power n dx is equal to x to the power n plus 1 upon n plus 1. So here students, write 3 as it is, and here it will become x to the power n is 11 by 2, n plus 1, 11 by 2 plus 1 upon 11 by 2 plus 1. In denominator will be n plus 1. So here students, if you will evaluate this, it will come out to be 11 by 2 plus 1, 11 plus 2, 13 by 2, x to the power 13 by 2, and here also same 13 by 2. And students, if you will simplify this, it will come out to be 6x to the power 13 by 2 upon 13. So students, in this way you have to evaluate your integrals. Now students, there are other useful formula, but this one is most frequently used. X to the power n dx is equal to x to the power n plus 1 upon n plus 1 plus c. This is most frequently used formula in physics also. So you have to remember this. Now student, next is, there are some other useful formula. If you have function fx in the form of integral of 1 upon x dx, so students, the integration of this will be how much? Log base e x plus c. And students, integration is just the reverse process of differentiation. If you have d by dx of log x, then what is the differentiation of this? 1 upon this. And we always use integration constant in indefinite integral, because students, function having the same differentiation, they differ by constant. So just to minimize this, we use integration constant while evaluating indefinite integrals. Now students, next is, suppose if you have function fx of the form of sin x, then students, integration of sin x dx, it will be equal to how much? Minus cos x plus c. And students, if you have differentiation of, sorry, if you have differentiation of cos x, then what you will get? Minus sin x. See, here integration of sin x is cos x and differentiation of cos x is sin x. So integration is the reverse process of differentiation. And students, if we have function in the form of if you have function in the form of cos x dx, here we are integrating cos x with respect to x, so you will get sin x plus integration constant c. And students, if you have differentiation of sin x, then students, you will get cos x. Now students, if you have integration of e to the power x dx, then you will get e to the power x plus integration constant c. And students, if you have to differentiate ex, e raised to power x, then students, here you will get the same function, e raised to power x. Now students, if you have integration of fx, and fx is in the form of sec square x dx, then students, you will get tan x plus integration constant c. And students, if you have differentiation of tan x, then students, you will get sec square x. And students, if you have integration of dx, then students, you will get x plus integration constant c. This is also very important. If you will integrate dx, you will get x plus integration constant c. So students, these formulae you have to remember at least. And the power formula which I gave you in the starting, that is the most useful formula in physics. You will get number of times that power formula. Now students, the next topic is definite integrals. The next is definite integrals. Definite integrals. So let me upload one diagram for this. So now, students, see, this is the diagram, and this is the curve y is equal to fx, and there is a very thin strip. The width of this strip is dx and length is y, and there is a curve, students. There are two limits, x is equal to x1, it is called lower limit, and x is equal to x2, it is called upper limit. Now, students, we will talk about definite integrals here. Definite integrals. Now, students, see what is definite integral. Students, when integration is performed between the given limits, when integration is performed between the given limits, then it is called definite integral. Now, students, here x is equal to x1, it is called lower limit, and here, students, x is equal to x2, it is called upper limit. Upper limit. And students, definite integrals are performed in the same way as indefinite integral, but there is only one difference. If we are evaluating definite integral, uh, we have to evaluate definite integral without adding integration constant. Without adding integration constant. So students, if you are evaluating definite integral, you have to evaluate definite integral without adding integration constant. So you have to avoid integration constant in definite integral. Now students, if you have the function y is equal to fx, and students, we are integrating fx between the limit x is equal to x1, it is lower limit, and x is equal to x2, it is upper limit, students, and we are integrating it with respect to x. So here, students, if the integration of fx is capital Fx, it is capital Fx, and the limits are x1 and x2. So students, it will be equal to upper limit, that is f, x is equal to x2. So here x2 will come minus f, x is equal to x1. Upper limit minus lower limit. Now, students, for example, let me give you one example. Suppose you have to evaluate the integral uh, between the 1 to 3. The lower limit is 1 and upper limit is 3, and it is 5x cube dx. So, students, take 5 outside because it is constant. 1 to 3 x to the power cube dx. Now, students, we know one rule. If we have y is equal to x to the power n, then integration of x to the power n with respect to x is what? X to the power n plus 1 upon n plus 1 plus c. C is a constant of integration if we are evaluating indefinite integral. But students, here we are evaluating definite integral, so we don't have to use here integration constant. So students, compare it. So here students, what is n? N is 3. So here 5 into x to the power n plus 1. 3 plus 1 will be 4, and 3 plus 1 will also be in denominator. And the limits are 1 to 3. So here students, if you will evaluate the, take 4 outside, 5 upon 4, 3 to the power 4, upper limit x is equal to, you have to put here x is equal to 3, upper limit minus lower limit is 1, 1 to the power 4. So students, here, if you will evaluate this, simplify this, 5 upon 4, it will be equal to how much? 3 3 ja 9, 3 ja 27, 3 ja 81 minus 1. It will be 5 upon 4 into 80, and 420, 25 ja 100. So 100 is the answer. Now students, we will solve one more problem based on limit. If we have integral 0 to pi by 2, upper limit is 0, lower limit is 0, upper limit is pi by 2, cos x dx, cos x dx. Then students, if you will integrate, integration of cos x is what? Minus sin x. So here minus sin x, and the limits are 0 and pi by 2. So now students, here what will happen? Minus, so here students, sine, upper limit is pi by 2, upper limit minus lower limit, sine 0. So here students, what will happen? Here sine pi by 2 is 1, here it is equal to 1, and sine 0 is 0. So here you will get minus 1. So the answer will be minus 1. So students, integration of cos x between 0 to pi by 2, what we are getting? We are getting, sorry, sorry. Here integration of cos x is sin x. Sorry, done one mistake. So be careful. Integration of cos x is sin x. So here answer will be plus 1. Here answer will be plus 1. And students, if you will integrate sin x, then it will come out to be minus cos x. And students, for that, I think uh, answer will be, I think, plus 1. Let me integrate. Let me verify. If you have sin x between 0 to pi by 2, and if you will integrate this sin x minus cos x 0 to pi by 2, and what is upper limit minus lower limit minus cos pi by 2 minus cos 0. And students, if you will simplify this, cos pi by 2 is how much? 0, and cos 0 is 1, and minus minus 1, it will be plus 1. So again, you are getting plus 1. So students, this was all about definite integral. Next, students, we will see application in physics. What is its application in physics? Application in physics. Application in physics. Now, next. Students, integration is used in physics in two ways. We will see what are the two ways. First way is to determine the area, to determine the area under curves. Determine the area under curves, which represents the quantity having dimension of the product x, y. We studied now one curve y is equal to fx and there was two limits x equal to x1 and x is equal to x2. And what we are doing, we were integrating that what y is y dx. Y was what? Length, and dx is what? Breadth. So this is nothing else but it is area. And students, if you will integrate it between x is equal to x1 to x is equal to x2, what it will give? It will give the summation of all the small area between the limit x is equal to x1 to x is equal to x2. But students, here integration is doing what? It is saving your time, and it is also making your life easier. You just have to consider one area and you have to integrate one area between the limit x is equal to x1 to x is equal to x2. If you will be able to do the integration, then students, you will be able to find the summation of all the area between x is equal to x1 to x is equal to x2. So student, this is the first application of integration in physics. Now students, second application is, we will see second application. What is second application? Students, to extend the result on a very small element to the entire range. To the entire range. I am repeating once more, to extend the result on a very small element to the entire range required in the problem. So these are the two application of integration in physics. And friends, here in kinematics, we will study one unit, kinematics, in physics. This is second unit. So I am not going in detail about kinematics. The area under the velocity time graph, the area under the velocity time graph, it will represent what? Displacement, because displacement is equal to velocity into time. And students, or students, speed time graph, if we have speed time graph, it will represent what? Distance. And students, the area under the acceleration time graph, if we have acceleration time graph, and the area under the acceleration time graph, it will give the velocity. Just have to take the product. Acceleration into time is equal to velocity. And students, when your velocity is, students, when your velocity is expressed as a function of time, when your velocity is expressed as a function of time, then student, to determine the displacement from time t is equal to t1 to time t is equal to t2, what we do? We integrate the expression between the limit t is equal to t1 to t is equal to t2. For example, we have, if we have velocity and that velocity is function of time between the limit t1 to t2, and students, if you will integrate it with respect to time, then what it will give? It will give displacement. It will give displacement. Displacement. So here, friends, this VT dt under integration, it is representing what? It is representing the area under velocity time graph, and it will give displacement. Now, friends, suppose your velocity is, let me give you one example. Suppose your velocity is function of time and it is given by 2t plus 3 meter per second. The unit of velocity is meter per second, and time intervals are t1 is equal to 1 second, and t2 is equal to 4 second. Then, students, if you will integrate your velocity with respect to time, then you will get displacement. I'm representing displacement by s. S is equal to 1 to 4 second, because t1 is 1 second and t2 is 4 second. 1 is lower limit and 4 is upper limit. And students, velocity is 2t plus 3 dt. Now, students, next, if you will integrate this, how much it will come? S is equal to, take so students, here 2 is what? 2 is constant. 2 is constant here. So here it will 2 will go outside. Then here, students, 1 to 4, we have to integrate t, and here plus t dt. We have to integrate t with respect to t, plus 3 we will keep outside. And here, students, 1 to 4, and here it will be dt. So, students, here displacement s will be equal to 2. And here, students, the integration of t, power is 1, x to the power n plus 1 upon n plus 1. So here it will become t square by 2. Limits are 1 and 4, plus integration of dt, it will be t, and the limits are 1, 4. Now, students, if you will solve this, it will come 16 by 2 minus 1 upon 2 plus 3 into 3, upper limit minus lower limit. And students, here 15 plus 9, and here, students, you will get 24 meter. So, students, we have easily calculated displacement by integrating your velocity with respect to time. So, students, integration is doing what? It is saving your time, and it is also making your life easier. So, students, and what is the meaning of this? By adding all tiny distances covered from 1 second to 4 second. By adding all tiny distances covered from 1 second to 4 second, we will get displacement is equal to 24 meter. But students, with integration, you can easily calculate your displacement, that is 24 meter. So if you have any doubt, students, you can ask your doubt on my email ID, sumitcoleman@gmail.com, @gmail.com. And students, you can join on the classroom also. I will share the link of classroom in the on my YouTube description, so you can add there and you can discuss your doubt with me. And if you have liked this video, you can like, share, and subscribe my YouTube channel. That's all. Thank you.